what we are, the direct data of these techniques, fMRI, PET, are things that are happening in the blood. The blood that is, there is a logic and is justified, that logic to explore the brain, and for neuroanatomists and neurophysiologists is very useful to characterize and to have images of the brain. But it's not a direct, completely direct observation of the activity of the neurons. It's in the indirect observation of the activity of the neurons. And there's a lot of inference to finally connect what is happening really in the neurons at different levels, probably is in a very micro level what is relevant, and we cannot detect it with these techniques, with respect to the macro level of psychological processes, perception, memory, language, thought, etc. In any case, this neuroculture has had a big influence in the public in general. And I want also only to mention this experiment that is related in several parts, and I have found it in different consultations that I have had for preparing this talk. This experiment that was made in Yale University by Weisberg, Kale, Goodenough, there are 4 or 5 authors. It was with experts and non-expert participants. Expert mean people that have some formation and education in cognitive neuroscience, in neuroscience in general, and non-expert just public in general. Students of the university, etc., but and had to rate in a 1 to 7 scale. They gave them first a phenomenon or a psychological effect that have been tested, and then 4 kinds of explanation on that effect: good explanation and bad explanation. And there were 4 conditions. It was a 2x2 design, because each kind of explanation, good and bad explanation is in point to, it was just a reformulation, was circular, was a different way of saying the same thing as the effect is described to begin with. And the good explanation is a good explanation of causal and effects that have been supported by the data, and the effect has that good explanation. But those explanations, in principle, didn't require, they were psychological explanations, didn't require appealing to neuro processes, to locus of the brain that have been, but in the the other factor was precisely a fourth, a neuroscientific commentary to the central explanation for the good and for the bad. That neuroscientific information, the addition of that neuroscientific information was the same. Was the same for the good and for the bad explanations. For the experts, they were not different. That neuroscientific explanation didn't make any difference for good and bad, and for with that or without that explanation. But for non-experts, and that's the public in general, that's the public that read the newspapers, that's the public that is exposed to those news that appear in the first page of many magazines and journals about neuro. Well, a couple of weeks ago was a neuromoda in El País, a big report of neuromoda, how our brain chooses the colors and the dresses and is seduced by the models. It's exposed, but the non-experts, effectively, in the third point, the addition of the neuroscientific information that was irrelevant, there's the cerebral location of the effect, rendered the bad explanation satisfactory. In that scale, there was a significant difference between the rating that they gave to the explanation with the neuroscientific commentary or without the commentary. Without the commentary, it seemed bad. But the same explanation, bad explanation with the neuroscientific commentary seemed good. There is kind of allure of seduction, attraction, special attraction. It looks like if these difficult problems that the psychology has to deal with from the beginning and little by little we are doing some certain progress, it looks like disappear by art of magic with the information about the neural. But what they are saying, Javier San Pedro, that is the scientific commentarist of El País, from time to time appears with those in a kind of divulgative sense. It looks like it seems that he reads Nature or Science and he tries to transmit the content of those scientific papers to the general public. And it has these titles. We are one step far away from reading the mind. We are going to read the minds of the people very soon. Is what he said, because of a very specific, if you read the original paper in Science, it was about perception and about the visual neurocircuits that are involved in certain visual performance, perceptual performance, very specific, more or less, not very different from the ones that Hubel and Wessel, without these technologies, discovered 40 or 50 years ago, and they won the Nobel Prize. We are just one step to read the mind. It's and probably, I don't know, the general public, I think it's not honest to make this kind of propaganda of the neuro results. 5 minutes, less than that. So I think that to end up this part of the talk about the neuroboom, the critical approach to cognitive science that I have followed and that I had to develop in these papers that I mentioned at the beginning can be reduced or can be summarized in these 3 points. I think there is a confounding of means with ends. By means, I mean the instruments, the big advance in technology to be able to explore the brain circuits, the brain processes, and the brain anatomy and physiology. But that's not explanation. So just to find which kind of things are lighting when you perform certain things doesn't show anything important about the explanation of those behaviors, of those achievements, of those capacities, of those. You need a functional level of explanation in a more abstract sense. David Marr, that was so influential in the psychology and perception, and think that perception, for example, is the field in psychology that is closer to make advances in neuropsychology, in the neuro, because our perceptual systems are so well based on the sensory systems, are so well, so clearly designed, and we have access directly. It would be a good luck to have in other fields of psychology like memory, thought, language, the same advantages that we have in perception, in the perceptual systems, to contrast and to correlate neurophysiological areas with respect to achievements. But think of David Marr. Probably you had done this perception, so influential in visual perception. David Marr had an education in physiology and in neurophysiology. His doctoral thesis was on the cerebellum and certain functions of the cerebellum of the cat. And then he was a mathematician, made cognitive science, and ended his life very soon, of course, by a cancer at 40 years old, in a department of psychology. I had the privilege of meeting him personally 1 year before his death. That was very busy trying to finish his only book. Many papers, but only one book that has been re-edited by Alianza editorial in Spanish, and no, by MIT Press, I'm sorry, and I don't know if Alianza, that was the publisher of the first book in Spanish, has also made this second edition. That was post-mortem. He didn't see the book appear. David Marsh says, even if he knows a lot about neurophysiology, he says it's important to know the machinery of the system and the basic components of the system, the implementation of the system. But to understand what mission is, what vision is, like any other perceptual performance, you had to move in another more abstract level. He called the theory of computation or computational level. You had to understand what kind of problem solves the organist when he sees a tree, or he recognizes a melody, or what kind of task or problem is he solving. And to develop a theory of the way in which the organist functions and solves that problem so easily, like in perception is usually, so efficiently, so rapidly. But you need a theory. You need a theory always when the output of the system is not the same, it's not homomorphic or isomorphic with the input. And if you describe carefully the input of the system, the sensory system, and the output of perception, you see a lot of discrepancies. So you need a theory in the middle to fill this gap. And that theory is not achieved looking at the brain, looking at the cells of the brain, looking at fMRIs. Like David Marsh said, you don't understand what flying means looking at the feathers of a bird. Looking at the feathers of a bird, even if feathers and of the bird are the instrument for the bird flying, you don't gain any understanding of what flying consists of. So probably our psychological function is more or less the same. That's why the two other things, confounding levels of exploration, I have referred to that before, because talking about even the brain, you have to distinguish the things that we have access with these new technologies and more microscopic things that are not accessible directly with these technologies. And confounding levels of explanation is that neurology or neuroscience has a level of explanation, is more basic probably than psychology, but is different from the level of explanation of psychology. Finally, as conclusions, I would like just to read the things that I have put here, that in conclusion, and for a position, to take a position in the matching or no matching problem about neuroscience and psychology, I would say that neither Cartesian dualism nor reductionism, the two ends of the spectrum, are acceptable for science or psychology. Scientific psychology is possible because we have overcome these two ends of the thing, and with functionalism and with a functional level of explanation, and taking seriously that mental life has real properties like intentionality, compositionality, etc., is where we can make scientific. Computer science has afforded and has provided us with good means to model the mental life, like because like Turing was proposing, we are certain that a physical system, like we are a physical system, the test of existence of intelligence in a physical system through computation, through manipulating symbols, can achieve and solve problems and do a kind of intelligent action. Secondly, a corresponding object domain and a proper level of explanation. Psychology has to maintain that and to avoid any temptation of reduction. In defining his object domain and his proper level of explanation, is possible to consider the autonomy for psychology, even if, as I say in the third conclusion, psychology and neuroscience can be considered as two well-differentiated neighboring disciplines, but as they are neighbors in the scale of the specialization of sciences, Neuroscience is not the most basic science. Chemistry, biology, chemistry and physics can be reduced, that even if it has not been proposed. The possibility of interaction and mutual benefit. But if I speak about interaction, is because the interaction had to go in both ways.